Hi everyone, so today our lesson is on polynomials, okay? And polynomials come after what we just learned in our last unit, which is quadratics. So, in your notes, there is this PDF uploaded. I want you guys to pull it up and fill it out as I go along, okay? So, the first thing we are going to do is in the middle, we are going to write the word polynomial because that is what we are talking about. This is our new unit, okay? And what we're doing right now is no math is going to be involved. We are just going to learn how to label and name polynomials, okay? Because there's a variety of them. But the first thing we need to do is we need to define a few things, okay? So the first thing we're going to do is we're going to define a polynomial. And a polynomial is an expression that can have constants, and we'll talk about what a constant is later, variables, and exponents. But, this is important, but there's three things that we need to focus on. And what it can't have is that when we're looking at a polynomial, there's no division by a variable. Okay? Also, there's only whole number exponents. So a whole number is just 1 and up, right? We can't have any fractions, no negative numbers, no decimals. And the last thing we're going to talk about is it can't have an infinite number of terms, okay? And we are going to go through those blue parts of our definitions in the non-example, okay? But we're going to talk about something else first. So now what we're going to talk about is the characteristics, okay? And labeling a characteristic is like labeling maybe a personality trait. So I would just characterize myself as brown hair, medium height, brown eyes, a teacher, okay? So what the definition for characteristics are that we're going to write here is polynomials are named by their degree and number of terms, okay? And we're going to talk about that more on the back page, but I just want you guys to get this down, okay? So if you need to pause and write it down, pause and then play it, and you'll hear the next part, okay? So now what we're going to talk about are examples, okay? And what an example of a polynomial looks like is this. So 5x cubed plus 7x squared minus 2x plus 16, okay? And when we're looking at examples and when we're doing these, I want you to ask yourself two questions. So the first question is, how many terms are there? Okay? And a term is each set of numbers. So anything that's broken up by a subtraction sign or an addition sign, okay? So in this problem, I see 4 terms. 1, 2, 3, and 4. Okay, so I'm going to write my answer as 4 terms. Okay? And then the second question we're going to ask ourselves is, what is the biggest exponent that we see here? Okay? And here, what I want you to do is I want you to circle the biggest exponent. So in this case, we see that the biggest exponent is 3. Okay, so you're going to ask yourself those questions every single time we're doing one of these examples. And now we're going to go back up to this blue part, so our non-examples, okay? And one non-example would be something like this, 2 over x, which correlates to that first blue part in the definition where we can't divide by a variable, meaning there can never be an x or a y or a letter in our denominator or under the fraction bar. Okay, non-example number 2 would be something like 5x to the half, right? Because we can only have whole numbers, and a half is not a whole number. And the last non-example would be something like x plus y to the negative 2, which makes it, right? So that's another exponent that is not a whole number. Okay, so this is our front part. If I went too quick, please pause, go back, reverse, whatever you may need. But I want this chart filled out, okay? If you're not going to fill it out on Cami, that's fine, but it needs to be filled out on something, okay? This is a new lesson. We haven't learned about this at all. and you didn't learn about it at all last year. So this is brand new to you. So notes are super important, okay? All right, on to the back. Now, this side is even more important, okay? Because what we're gonna do is we are going to define what a degree is and what a term is. Because when we label polynomials, we label them by their degree and by their terms, okay? So in this first box, what I want you to do is write down what we're looking for when we look for a degree. So for a polynomial with one variable, the degree is the largest exponent of that variable, okay? So we are just looking for the largest exponent, okay? And this is in terms of degree. So now we are going to go through the degrees that we may see, and we are going to list their names so you know how to correctly name the polynomial, okay? So when we have a degree of 0, okay, the name of that would be a constant, okay? Because when you don't have a degree, nothing can change, right? There's no variable, there's nothing there. So when you have a constant, what a constant, an example of a constant would be just a number. So for example, 3, that's just a constant. There's no variables, there's no exponents, it's just the number itself. Then we move on to when we have a degree of 1. And what that is called is linear. Okay, and an example of something that's linear would be something like this, where we just see a variable with no exponent, because we know technically that after that x, there's a little exponent of 1. Okay, but we won't see that, so I don't want you guys to write that. So you just have to remind yourself that whenever you have just a variable with no exponent, it's linear. Okay, and then on to the degree of 2. And what this is called is a quadratic. So this is just the unit that we went over, right? And what a quadratic will look like is with an exponent of 2, right? So whenever the highest exponent is 2, we call it a quadratic. Then we're going to move on to when the degree is 3. Okay, and the name of the degree of 3 is called a cubic. And an example of what that would look like is y cubed plus y squared minus 4, where the biggest degree is 3. Okay, and then when we move on to the degree of 4, when our biggest degree is 4, the name of it is called a quartic. Now, I know this is a tricky word, right? It's a weird word, quartic. And what an example of that would look like is x to the 4th minus 3. So whenever we see an exponent of 4. Then we're going to move on to when we have an exponent of 5, okay? Okay, so when we have a degree of 5, the name of that is quintic. Okay, I know these are challenging words. I'm not going to really have you say them. We just need to be able to write them. And what a quintic expression would look like is when the degree, the highest degree is 5. So something that would look like that. Okay? And then the last one we have is 6 plus. So any time you have a degree of 6, 7, 8, 9, 10 to infinity, you're going to call that the 6th degree. But what changes is that ... the next one will be called the 7th degree and on, okay? So if you have an exponent of 10, it would be the 10th degree. There's no special name for that, okay? An example of this would be z6 to the 6th degree plus z squared, okay? So that's what we're going to look for, and those are the names that we're going to use, okay? Now we're going to move on to the next part. When here we're going to talk about terms. So we're going to talk about what we are looking for when we look for terms, okay? And what we're going to write here are terms are always separated by addition or subtraction, okay? So really what we're just doing here is we are looking for how many terms are in the expression, okay? And I'm going to do the same thing that we did on the left side with the names of the degree, but now we're going to name terms, okay? So the first one we're looking at is 1, right? If we don't have a term, if there's no terms, then there's no expression. So we are not going to label something as 0 terms. Okay, so the first thing we have is when there's one term. And when there's one term in an expression, it's called a monomial. Okay, because mono means one. An example of this would just be something like 3x. Okay, when we have two terms, it's called a binomial. And an example of this would look like this, 2y minus 4, where 2y is a term and 4 is a term. Then we move on to 3 terms, and what that is called a trinomial. Tri meaning 3. And an example of this would be like x squared plus 3x plus 9, where x squared, 3x, and 9 are all different terms. Okay? And the last one is anytime you have 4 plus. So anytime you have 4 or more terms, it's called a polynomial, which is our whole unit. Okay? And an example would be something like y cubed minus y squared plus 2y minus 5, where y cubed, y squared, 2y, and 5 are all different terms. Okay? Now, before we do some practice of this, I want you to know that when we label or when we name, okay, what comes first? So the degree comes first. So degree first and term name second. Okay? So you always want to give the degree name first and then the term name second. So we're going to do a few examples, okay? So when we're looking at this first example, -7 plus 3n cubed, the first thing I want you to do is notice what the exponent is and give it a circle. So I know that the exponent here is a 3. So I'm going to come over to my chart here, and wherever I see the degree of 3, I know that the name is cubic. So that's going to be the first thing I write down is cubic. Okay? And then I need to count my terms. So I have a -7 is a term, and 3n cubed is a term. And when I have 2 terms, because I only have 2 terms here, it's called a binomial. So this whole expression, this whole polynomial is called a cubic binomial. Okay? All right, so now I'm going to look at the second term. All right? And here, I don't see any exponents. So there is no degree, there's no exponent. So I know that when there's no exponent, it is called a constant. Right? Because when we have 0 exponents, it's called a constant. Then I come over to the terms, and I know that 5 is just one term. There's nothing else there. So that's going to be called a constant monomial. Okay? And then the last one, what we need to do is I see exponents. So I'm going to go ahead and circle the biggest exponent that I see, and that's 4. Okay? So I'm going to come to my list over here, come to 4, and I know that the first word is going to say Quintic. Okay? Then I'm going to count my terms. So I have a term here, a term here, a term here. So I have 3 terms, and that is called a trinomial. Okay? Sound good? Before you leave, I want you to just write this example down because I don't have one on here. So say we have something like, let's go through 5y to the 5th plus 3y squared plus 2y minus 6, okay? Here, my exponent would be a 5. So this is called, the first thing is called a quintic, okay? And then here I have 1, 2, 3, 4 terms, okay? And we know that when we have 4 terms, it's called a polynomial. But what I want you to do is after you write polynomial, because any expression that has more than 4 terms is called a polynomial. So what I want you to do is in the parentheses, you're going to write 4 terms. If it's 5 terms, you'll write 5, and so on. Okay? So you have 30 questions for homework. They are just like these 3 examples. Okay? So you're just going to be doing the same thing. All you're doing is naming. There's no math being done. If you have any questions, let me know.